Howdy everyone, my name is Jasan, and in this video I'll demonstrate problem submission on Physforces. For demo purposes I have selected mass of triangle problem, where we have to find mass of a uniform uh, triangular board, and the dimensions and the density of the board are given to us. So all we have to do is type in the solution and be able to submit. Uh, we can select from two choices of syntaxes. First is default syntax, and next one is LaTeX. So let me get started from default syntax. Default syntax is the recommended way, as it requires a little bit less typing than LaTeX syntax, and it's very similar to um, digital calculators used nowadays. For math expression equivalent annotations, you can refer to the quick syntax reference box under the solution form. And if you expand it, you'll be able to see that on the left side there are mathematical expressions, and on the right side the equivalent annotations in corresponding syntax. So let me type in the solution. So first, so you can type solution. You can format your solution in any as you like. You can flatten out the whole solution and just submit the final expression, or you can break it down to a intermediate variables and then work it around. But it's up to you. So this is how I would solve this problem. So I first find a um, height of the triangle, which is a multiplied by sine pi over 3, and then I would find the surface of the triangle board, which is h multiplied by a over 2, and I would find the volume, which is a multiplied by d, and I would finally find the mass, which is v multiplied by the density, and finally my answer is m. So now I have, since I have finished typing my solution, I have to verify that my expressions are interpretable by the system. To do so, I can hit the small tiny button above the solution box, and it'll display terminal-like window below the solution box, which indicates whether your expressions are understandable by computer or not. In this case, every expression is highlighted by green, so that means all the expressions are okay. If we make a mistake, for instance, if we forget to add something or add some syntactical error and try it again, it will indicate that in line VA multiplied by D and in all the following lines, there is an error. So I'd recommend using this debug button to verify quickly whether your expressions are valid or not. And after we have verified, we can submit the solution and see the result. If it's highlighted green, then it means that your solution is accepted. Great. Now, let's do the same on LaTeX syntax. In LaTeX, you can notice that the first line is reserved. So you're not supposed to change that. Therefore, you have to start typing in your solution from the second line. And another thing to note in LaTeX is that this is actually a web version of called KaTeX, which is a little different than the actual LaTeX syntax. And even for KaTeX in Physforces, we limit the available syntaxes for only common ones. And you can refer to the available notations in the quick syntax reference bar below the solution form, as I have mentioned before, and you would see here the mapping from the math expression to a KaTeX notation line by line. So you can use that as a reference. As you see in KaTeX, we also format our solution in a LaTeX document type, so where every expression have to be surrounded by singular or double dollar signs. Um, so, um, again, you are free to format your solution in any way you like. If you want to flatten out to a single expression, go ahead and do it. Or if you would um, approach the solution in a different way, that's also up to you. But I will just replicate what I have typed in default syntax for latte. So first I found h, which is the side sinus side multiplied by sine of 60 degrees, which is pi over 3. And next, the surface area was about a multiplied by the height by 2. Then the volume was the thickness multiplied by the surface area, and the mass was volume multiplied by rho. And as we have typed our equations down, we can verify whether our system can understand them by hitting the same debug button above the solution box. And we see every expression is highlighted with green, which means all of them are at least understandable. Now let's make a mistake. Let's do something. Let's forget something. I don't know. Let's do some mistake. Something like this, for instance. And see what it says. It indicates the error in the same way as it was previously. So we can correct it back and check in again, and we see everything is okay. So you can play around with it, make different mistakes, recommend it. Now we can try submitting it and see whether our solution get passed. Yes, as we see here, our solution is highlighted with green, which means that it's correct. Now let me demonstrate something a little bit more interesting. Let me try to show how to solve this problem with integration. I'll be focusing on integration part. I will not deep dive into the solution details. You can look the explanation up from the official solution here, which explains everything pretty much in detail. But I'll just go back and demonstrate the how to use the syntax basically. I'll first start with default syntax and then we'll get back to the latex. Okay, let me start. So basically we defined the height as a multiplied by sine pi over 6, pi over 3, sorry. So, and then here comes our integral. So we do, oh, by the way, to integrate, we are actually slicing up the board into thin slices from bottom up and integrating over coordinate y. So for integration, we can look up the notation here available in the default syntax, which looks like this. So we need a bounded integral. So what that means is that if you have an expression y that depends on variable x, we can integrate it over over the variable x from a to b. So that's integral could be represented as this one. Okay, let's do that. So let's integrate, and we can type here first our expression that we are going to integrate over. So which is density multiplied by the thickness multiplied by a 2 y coordinate. Y coordinate, let's imagine that it starts from top to bottom, multiplied by a sine um, pi over 6. Um, and then that's our integration, and then we are going to integrate it over y, which changes from 0 to h. Now let's try if computer understands it. Oops, it says undefined variable or operator detected in this here. So we look up here and say, what's y? We don't know why. So although it's a variable that's used for integration as a coordinate, we first have to declare it. We don't have to define it, but we at least have to declare that assume some y. So just necessary to type y in a new line. That's enough. And if you now try it, yes, it understands. So we can try submitting it. So it means that, again, this is syntactically correct. So okay, the system is able to understand it. But we can only know if it's actually correct solution by submitting. Oops, it says it's not correct solution. So we have made a mistake. So what we have forgotten. So we said the density multiplied by d multiplied by 2y multiplied by, oh, this should be tangent. It's not sine. Okay, so here we go. You can check whether computer understands it. Now we submit. Yes, and now it's correct. Again, I'm not going to dive into this details why I wrote here. If you wonder, you can look that up from the official solution. Now let me retype everything I wrote here on a LaTeX syntax for demo. So first define an age, which is sine multiplied by sine fraction pi over 3, and our integral. So remember, we had to define y, so we define here y. This is the variable that we're going to integrate over with. So integral syntax. Now the integral syntax we can look up from the quick syntax reference. As you see, the integral in LaTeX is notated like this, so we have to type similar thing. So integral from a from 0 to h. That's what we're going to do. Better actually surround for clarity. And then the body of integral would be, so we're actually trying to integrate rho multiplied by d multiplied by y multiplied by tangent of y over 6, and we forgot to multiply by 2 as well, since we have two sides. And then we are going to integrate by a y, so we type here dy, and then let's check whether the system can understand it. Oh, it says it cannot understand it. It can't even render it. So we have made a mistake somewhere. Now I have to debug it. Unfortunately, it doesn't tell what's the mistakes. It's unfortunate limitations of the system. So where we have made a mistake, so it's gonna roll 0. Somewhere it has to be somewhere in the braces. So we have this one. So we've closed the fraction, we closed the tangent. Oh, we didn't close the tangent here. I think, now let's try. Oh, yeah, now it basically understands the equation. For clarity, let me send back the tangent, because it's kind of a constant actually. Send it back. That's that way. So essentially, we can actually also like separate out all the constants and put forward, but that's just some clarity stuff. And for demo purpose, I just stick together and then see if it's actually system accepts it. Yes, it's accepted. So this is the correct solution. Great. So that would be it for this video. I'd recommend also visiting the tutorial section and learning more tricks, play around with other problems. Thank you for attention. Bye.